So I'm going to break down some of the questions. You can fast forward, see what you need to have. But the first one that we're going to do, number 1, what is the length of the altitude to the hypotenuse in a right triangle? So if we have a right triangle, the altitude is this one, right? And it says that this altitude divides the hypotenuse into segments of 8 and 18. So this altitude. Now that altitude is the geometric mean. So that means that a squared is equal to 8 times 18. Well, 8 times 18 is 144. So the square root of that A is going to be 12. And 12 millimeters. So once again, I have PS right here. PS is the altitude, that's 6, and PT is 9. So I want to find this one. I'm going to call it X. Now PS is the geometric mean, so it's going to be 6 squared is equal to 9 times X. So 6 times 6 is 36, and that equals 9X. We divide by 9, and X, which is our PR, is equal to 4. On number 3, we had to use the special right triangles, and let's just remember what those ratios are. So if I have 45, 45, 90, and a 30, 60, 90, all the short sides get 1s. The hypotenuse gets a 2, and the long leg here gets a 3. And the largest digit of each triangle gets a radical. Now I want to know the sine of 60 degrees. Well, sine is opposite over hypotenuse. So 60 degrees, the opposite side is the square root of 3, and the hypotenuse is 2. On the cosine of 45, if I look at 45, I'm looking for the adjacent over the hypotenuse. The adjacent is going to be 1, and the hypotenuse is the square root of 2. But we want to rationalize that by multiplying by the square root of 2 over 2. That's going to be the square root of 2 over 2. Square root of 2 over square root of 2, sorry.